good morning. Hello, everyone, and welcome to this talk on Will Git Be Around Forever? My name is Hanno Embregts, and I am an IT consultant at InfoSupport. And I have been a Java developer for over 14 years. And at my first job, about 14 years ago, we did a revolutionary thing regarding version control. And I was really eager to learn it because at college, me and my students, co-students, we did version control by sending each other emails with zip files in it. And surely my employer would teach me something much more sophisticated in the world of version control. So I got at my first job and I was really excited to learn about how they would handle version control. And I got there and it turned out they did version control by USB stick. Well, I had never heard of version control by USB stick. So I was so eager to learn this, and it worked like this. So when you worked on a feature, you added the feature on your local machine. So you added the Java code to the existing code base. And when you were done, you would copy the files that you changed onto a USB stick and then walk over to a centrally placed laptop, which was called the integration laptop, that had the latest version of the code base on it. And you would put the USB stick in the integration laptop and open up the editors and try to merge all changes that you did by yourself into the existing code base. So a lot of manual work. And also, this integration laptop was actually a resource in our Microsoft Exchange environment. So you had to book the integration laptop to reserve a slot of time, like half an hour. And if you couldn't finish it in the time, you had to revert everything. So I was really disappointed. I was really eager to learn a very good version control method. And this is what I learned there. So a few years later, they switched to CVS actually, and I learned how to use CVS, which was also a bit old, of course. But if we fast forward 14 years again, so where I am right now, I have gained some experience with real version control systems like Subversion and Git. And because of my interest in version control, I also teach a course on version control at InfoSupport. We offer various courses mainly to get our junior colleagues up to speed with important concepts or products they will need for the daily work, like object orientation, automated testing, containerization. And one of the courses, so like I mentioned, is about version control. And the course is called Git for Developers. It's a one-day course where I teach the students how to use Git as a developer. So we focus on learning the commands and how they map to the buttons that you see in the GUI tools. But we also discuss the pros and cons of distributed version control systems and how they compare to the earlier version control systems like CVS and Subversion. This is actually one of the course slides, and it displays which version control systems have emerged until now and when they became available. And it also tries to put the publication date of each system in perspective by comparing them to the most modern mobile phone known at the time. So to give you an example, Subversion, which is right here in the year 2000, it corresponds to the Nokia 3310. I think everyone has had a phone like this one. And both Subversion and this Nokia phone were indestructible, of course. And another example, CVS, which emerged in 1990, relates to this ancient thing that even has a power plug. I haven't seen those in real life, but both CVS and this mobile phone are obviously ancient. Now, when I talk about this slide during the Git course, I tend to focus on the events of the year 2005, because for me, the year 2005 really stands out in version control history because 5 new version control systems were published in this year. Plastic officially in 2006, but TFS, Mercurial, Darkscape, and Bazaar all in the same period. And to put things into perspective, before 2005, it had taken 9 years for 5 different version control systems to appear, starting with VSS in 1994 all the way up to BitKeeper in 2003. So that's really remarkable. And it turns out there's a very interesting reason for the sudden emergence of new version control system, and it has to do with BitKeeper. So BitKeeper was the only distributed version control system that was around in the year 2005, and it was even used by Mr. Linus Torvalds to keep track of the source code of the Linux kernel. However, in 2005, April 5th, actually, it was announced that its licensing model would change. So it would go from an open source license to a proprietary license. And Mr. Linus Torvalds was not amused, to say the least. And he really wanted a free version control system. And maybe he had also been wondering how he could improve BitKeeper. So the first thing he did was start his own rendition of a distributed version control system, which later would become Git. But more people thought like that. So that is why in 2005, lots of version control systems emerged to respond to this BitKeeper licensing change. And a few years later, BitKeeper actually became open source again, but then it was too late. They had lost too many market share to the new emerging systems. Now, one day so at one particular course edition, when I was finished with the course, a student came to me with a question, and her question proved that she had noticed an entirely different thing about this graphic than I had. She came to me after class and she said, I really like Git, thanks for teaching me, but it's kind of old. I mean, what's going to be the next big thing? She had looked at this graph, but she had noticed the emptiness right here. Why hasn't anything new emerged after 2005, 2006? I'm really curious what I'm missing. So is there something around that I should learn already to be ahead of things? So I told her everything I knew, that I was quite sure Git and Mercurial would be around for a while longer, and that distributed version control systems were the way to go for the next years to come. But of course, this wasn't really a proper answer at all. I had effectively told her Git will probably be around forever, even if I didn't phrase it exactly like that. So the matter needed a bit more research. And the research eventually turned into this conference talk, which is the one you're attending right now. So welcome to you all, and let's see if we can find the answer to this student's question together, shall we? And after we find out, I'll make sure she gets the answer as soon as possible. Okay, I promise. Now, whenever I hear somebody say that some product will probably be around forever, it immediately reminds me of this quote, which he probably didn't even say exactly like this. It's very plausible that he added "for now" to the claim. And I think he added the "for now" because Mr. Gates knows very well that in the computer industry, change is the only constant. Now, this idea has been valid in our industry for as long as I can remember. And if you think about it for a second, you can come up with lots of examples. I mean, requirements change, priorities change, dependencies change, and if you work in front end, browser behaviors change. And to me, this proves that in our industry, change is the only constant. So we can already say, no, Git will not be around forever. It might be around for now, but eventually there will be a successor. The question remains, which one will it be? Which one will be the successor? And in finding the answer to this question, we obviously have to make a prediction. We have to predict which version control system will be popular in like 10 years. Now, throughout this talk, we will discover several ideas that can be useful to our prediction, and I will call these ideas prediction variables. At the end of the talk, we will use these variables to make the final prediction. And I think we can discover these variables quickly by gathering information on the current big thing and how it became the current big thing in the first place. So why did Git become so popular? Well, as you may already know, these are Git's main features. It's distributed like BitKeeper. You can commit often and push only once. It is free and it is open source, unlike BitKeeper, obviously. And it is fast. So Linus Torvalds said, everything you do in Git on a daily basis should take less than a second. And it has been optimized for branching. So like Subversion, Git has easy branching, but in the CVS age, developers were afraid of branching because it took such a long time, because a branch is effectively a hard copy of the root directory. In a time where continuous delivery didn't exist like we know it today, this was a very bad thing because it took ages to create a branch. When Linus Torvalds was developing Git, one of his guiding principles actually was, what would CVS not do? And if he was in doubt about a design decision, he would just look at what CVS did and make the exact opposite decision. So in a way, the features of Git are like the anti-CVS. And I think killer features should be our first prediction variable, because what I mean by killer features is that it has new features that have never been seen. or similar features, but implemented radically different, like Git did with features to implement in contrast of the implementation that CVS had. So let's use this one as a prediction variable, features that others don't have or implemented in a radically different way. I want to show you this chart to talk a bit about popularity. Now, there's a lot of information on it, so I'll go through it with you. First thing that I need to say is all data right here are approximations, because you can't measure popularity of version control systems like you can measure browser popularity, for example, because you don't know which systems everyone has installed on their system and how much they use it. So the data is like, it's combined data from Google Trends, GitHub, Atlassian, and GitLab, for example. So they are approximations. So any prediction we do based on this data will also be an approximation. But things that stand out to me in this graph is that Git and Mercurial were both growing until GitHub was launched, then Git started growing more quickly. And then Bitbucket, also a hosted version website, supported Git from 2012. Before that, it had supported Mercurial exclusively. But from the moment that Bitbucket started supporting Git, then Git was growing more rapidly, and it increased even more when GitLab was launched. And also Mercurial was growing until the moment that Bitbucket says, hey, we're not just offering Mercurial repos, we're also offering Git repos, and then it started declining again. Also, Subversion was very popular in like 2009, 2010. In fact, it was the top version control system, which was a bit after GitHub was launched, but slowly its popularity has decreased. Last thing I have to say about this slide is that TFS is now called, well, the TFS system is now Azure DevOps Server, and the version control part of TFS is now called TFVC, Team Foundation Version Control, which still shows up if you are in Azure DevOps and you want to create a new repository. You can choose to use Git or TFVC. So it seems that the available source code hosting for a particular version control system had some influence on its popularity. So this is also an important prediction variable, hosting platform support. And let's introduce the third one while we're at it. Your version control system may be supported by a hosting provider, but that doesn't necessarily mean that the same hosting provider supports the open source community in the best way possible. So lots of hosting providers primarily offer private repositories, for example, and not all version control systems focus as much on supporting open source development as Git does, for example. So here's prediction variable number 3, open source community support. I think that's enough about prediction variables for now. So let's try to make a first prediction, which at this early stage can only be done by using one approach, extrapolate from incomplete data. So let's take some existing data and extrapolate it. So if you would continue the trends that we see here, then Git will grow a bit and Subversion will decrease a bit more and so on. So the first thing I did is plot the percentages that are present in this graph for the year 2010. And this is what I came up with. So Subversion 43%, Git 19%, Mercurial 16%, and Team Foundation and CVS both a bit less. Now, if we would continue the trends that we see right here, so this chart is until 2016, but we want to see 10 years later, well, Git will increase a bit, and Mercurial and Subversion will decline a bit more, and TFS and CVS will stay probably the same. So these are the percentages that I came up with. Git will obviously was the most used version control system in 2020. Mercurial has declined a bit more, as you can see here. Subversion has declined a lot, and then Team Foundation and CVS at the bottom. And if we would extrapolate again for 10 years time, continuing the same trends, these are the percentages we get. So of course, Git's increase cannot continue forever, can obviously not go beyond 100%. So I put them at 80 to slow down their growth. Mercurial will decline a bit and Subversion will decline also a bit. So there you have it, Git will stay on top. I could say thank you for attending, everyone, until next time. But of course, I'm kidding, because there's one big problem. We haven't included any new products. This first prediction is based entirely on existing products, but a lot can happen in 10 years. So what if a brand new version control system gains the market by storm, we have to account for that. And this is exactly what happened during the browser wars, multiple times actually. So when I was in college, I did a talk on the browser wars. And in this college talk, I tried to predict what browser we would use 10 years later in time. And the talk was actually quite similar to this one, apart from the fact that my slides back then looked very different. This was actually one of the slides I used. So it's in Dutch, but that's not the worst thing. It's a very retro slide, the obnoxious headers and the obnoxious footers, which were repeated on every slide, by the way. Major waste of space. Also, this background gradient thing, what's up with that? Nobody uses that anymore. Page numbers at the bottom, just horrifying stuff. So maybe slide deck designs are like fashion. If we just wait for another 15 years, they will become popular again. Apart from the fact that it looks dreadful, this slide also shows that the Internet Explorer browser family in 2005 was very dominant. So you would add up these percentages, 6, 5, and 5.5. Almost 90% of all internet users used an Internet Explorer browser. Now, in this college talk, I predicted 3 things, and 2 of them actually happened. These are my predictions. In 10 years' time, IE would be surpassed as the top browser family, and Firefox would surpass IE also, and Firefox would be the top browser. Yes, I was a Firefox fanboy. Of these 3 predictions, only the last one didn't happen. Firefox never became the top browser. But the other 2 actually did happen, and I can show you some data that proves it. So the talk was in 2005. That's not on this chart, but this data is from 2007 to 2018. And Firefox is the black line, and all the IE browsers are the light blue line. And you can see that at this point in time, Google Chrome was the top browser and has been the top browser ever since. So the first prediction, and the second prediction was that Firefox would, at some point in time, have a larger market share than IE, and in 2016, this was the case. So technically, it took 11 years and not 10 years, but the prediction came through. So you could say that I do have some experience with this stuff. So let's hope that it goes, that it will be just as successful for the version control world. Now, the reason I was quite confident this would happen eventually, because of a mechanism that is called the law of the handicap of a head start. In Dutch, it is called de wet van de remmende voorsprong. So the Dutch historian Jan Romein coined this term in his essay, The Dialectics of Progress, in 1937, so quite a while ago. This law suggests that a group or individual that starts out ahead eventually will be overtaken by others. So the head start is an advantage at first, but ultimately it becomes a handicap. So this phenomenon occurs when a society wants it gets used to certain standards, but the standards change. Then it becomes a lot harder for the leading group to adapt. And this is exactly what happened during the browser wars. Society demanded tabbed browsing, and Microsoft had a hard time adapting to that. They just opened up new windows, very annoying. And this resulted in Firefox and eventually Chrome taking over, because they supported tab browsing much sooner. So just like in sports, it's a lot harder to stay on top than it is to actually get there. And the final prediction variable for this talk will be the handicap of a head start. The dominant product will eventually be replaced by a new one, like Netscape was replaced by IE, like IE was replaced by Chrome. And I can't think of a reason why it wouldn't happen again, and why it wouldn't happen in the version control world. So let's return to the version control world now and see which products we need to investigate as aspiring successors of Git. I'll be talking about 2 products in particular, Fossil and Pijul, because they were both published after this large distribution version control wave in April 2005. Sorry. I deliberately didn't choose to investigate products that were older than that, because they would have beaten Git by now. I can't imagine any product older than Git to still beat it in the future. I also used to have a VCS called Plastic on this list. I think it was in fact also in the abstract, but that one focuses primarily on game studios, where contributors work with graphics and other binary files. And also it's proprietary software. So apparently they haven't heard the BitKeeper story yet. I think it's a nice addition to the market. It fills a niche for the gaming industry. But because of that and the closed source license, I highly doubt it will replace Git in the end. So I want to focus on Fossil and Pijul in this talk. So let's talk about Fossil first. So these are the features that it promises. It's a distributed version control system like Git, and it offers integrated project management tools like bug tracking, wiki, forum, and tag nodes. It has a built-in web interface. Actually, the Fossil website runs on the same web interface. And it has an auto sync mode, which means after each commit, an automatic push is performed. But you can configure this so you can also use manual merge modes like Git and Mercurial work. It can show descendants of a check-in, more on that later. It supports operations on multiple repositories, so you can pull all repositories in a single command, Fossil all. And it has a preserve all history philosophy, which means there is no rebase in Fossil. All history that have occurred until now must stay the same. Also, this explains why it is called Fossil. It can't change, not for a million years. Quick facts, it was written in C and SQL, and it was even written specifically to support development of the SQLite project. In fact, they learn from each other because SQLite is using Fossil for version control, and Fossil is using SQLite to store its commits. You can use free code hosting at chisellapp.com. Or you can host it yourself because all commits are in an SQLite database. The only thing you need is an SQLite database and a web server. So no extensive requirements on that part. So this I already told you. This also means that each commit, so a check-in contains relations between both ancestors and descendants. This is radically different from Git because in Git, a single commit only knows which ancestor is the previous commit, but never the next commit. So producing a list of all descendants of one commit is very, very hard. Both native Git and GitHub don't provide this capability, but Fossil can do this. And it is also marketed a bit as GitHub in a box because you get all these features like GitHub, but you can just call them up yourself using the Fossil UI command with a local web server. So this means that it makes Fossil quite well suited for startups and small scale projects, but not really for large scale open source development like the Linux kernel. So enough talking, let's show how Fossil works for a bit. So I'll be showing how you get up and running, use the web interface, and retrieve a few descendants of a check-in. So I've got a terminal right here, and I've prepared a directory called Fossil. And we're going to create a directory called demo. And we also need to come up with a name for the SQLite file. I call it demo.repo in this case. Gives us some output. Then I need to change directories into the demo directory and link this directory to the SQLite file, which is what we do with the command fossil open demo.repo. In this case, they are linked and we can start adding some files. So let's use IntelliJ for that. There we go. Just a sample. I think I need to put it in the demo folder, and I need to mark it as source root because otherwise it won't see that it's a Java class. Oh, it is already a sources root. That's great. Yeah. Let's add public class sample. Sample. The contents is not very important for this talk, but I'll just have to add something in it. Let's add everything that we have. It says edit sample.java. Let's ask for the changes. It gives the same output. So if we want to commit, we just say fossil commit -m add sample. As we committed, it gives us a hash of the new version. And if we want to view, if we really want to view the UI, just say fossil UI. Here's the fossil UI. So this is what you get with a home page and the timeline. You can see this commit that I created just now and the initial empty check-in. You can browse the files in the repository, see the branches, see the tags, the forum, wikis. It actually looks a bit like GitHub in a box, I guess. Okay. So back to this one. I want to show you how to retrieve descendants of a check-in. So first I want to create a branch. I call it feature and I base it on the current branch right here. And we are going to provide an implementation for this class. And I just want to print a random number, very simple. I don't want to import anything. I just want to create a method. Thank you. And what do we return when we generate a random number? Well, of course, we can just roll die, right? I brought a die with me here. Oh, the filter is messing it up. I'm just rolling it right now, and it says 5. Hope everyone can see it. It says 5. So let's return 5 because chosen by fair dice roll. Guaranteed to be random. There we go. So let's save that and add it to our fossil directory, repository fossil commit -m provide sample implementation. And let's just see the UI again. Here. So we created a branch called feature, but we stayed on the current branch. So it has. So we just created the trunk branch right now. But what I can show you now is that we've got a commit that has 2 descendants. So this commit with the message add sample has 1 ancestor but 2 descendants. You can just open this commit in the fossil UI and ask for ancestors but also descendants, and it will see that it has 2 descendants. So 1 commit on the same branch and 1 on the newly created branch that I created. Very quick demo, of course, but just to give you an idea. Lots to say about fossil, but don't have the time right now, but you should sure read up about it. So if you are planning to use it, you should know that it has problems with dealing with large files and also large commits because it stores everything in a single SQL-like database file. So read this blog if you're interested in using it to see what you can do about it. When I was comparing Git to fossil, it really made me think about what is the right tool for the job. Because the sample project for Git is, of course, the Linux kernel, and the sample project for fossil is SQLite. But there's quite a difference in the number of contributors, 5,000 plus for Git and only 4 contributors for fossil. These 4 contributors really do know each other very well, so they have personal engagement. Whereas with Git, the Linux kernel, you don't know the next Linux contributor, could be miles away from you. And finally, the workflow that is used in developing the software also is influenced because with fossil, this is built on trust because you know everyone you work with. So you trust that the commits that they produce will be of high quality. Whereas with Git, you can't trust everyone. So this is why Linus Torvalds came up with a dictator-lieutenant collaboration model where he just trusts a few people with few components of the Linux kernel, and then the few people, the lieutenants, can trust committers below them. So this makes me really think about why are we using Git for everything that we do? Because it's a version control system that was designed to support a globally developed open source project like the Linux kernel. But are all our projects like that? Is your project like the Linux kernel? If I'm honest, most of my projects look more like a fossil project. Oh, there may be 8 or 9 developers, but never 5,000 plus. So surely something to think about. So let's go on to talk about the second version control system, Pijul. And the first thing we need to get out of the way is the name. So it's the name of, it's a Spanish name, and it's a bird that is native to Peru. The Pijul, and it's a bird that is known to do collaborative nest building. So this is the reason for the name, because of course, using version control system, you are collaborating. They have thought about changing the name to something more international, but they really like that this name is uniquely Googleable. So they've decided to stick with it. Features that Pijul promises also distributed version control. Meant to be simple to use because of its basis on the sound theory of patches. I will go into this a bit later. Fast, because it aims to fix the darks performance issue. I don't know if you're familiar with darks, but darks is also a version control system that is based on patches instead of snapshots, which has been around quite a while, but it never got very popular because applying these patches was very slow. So there's a small group of people that are using it, but it never grew that much. And Pijul tries to fix the performance issues. And it features interactive recording. I'll show this in a demo a bit later on. So a few facts about Pijul. It is written in Rust, which is one of the faster languages around. It has been bootstrapped since April 2017, which means they use Pijul for their own version control. So like IntelliJ, the people that work on IntelliJ, they also use their own IDE to develop their IDE, while the people of Pijul use Pijul to store their versions. So they eat their own dog food. And if you want hosting, it is available at nest.pijul.com, the Pijul Nest. That's the place you can add your public repositories. So let's talk about this patch-oriented design. So a patch is an intuitive atomic unit of work, and it focuses on changes instead of differences between snapshots. So Git doesn't store any patches, it stores file versions, which are called snapshots. And when you ask for the differences, it computes the differences by comparing the two files. Pijul stores the patches, so it stores the differences. Also means that applying or unapplying a patch doesn't change its identity. So it is also always identifiable with the same hash code, which is different from Git. And also the end result of applying several patches is always the same, regardless of the order in which they were applied. And Pijul does this by keeping track of dependent patches. I will show you this in the demo a bit later. Also means that there are no merges or rebases. So applying a patch is like Git cherry pick. And if you want to apply multiple patches, well, then you just apply multiple patches. So no merging or rebasing. So I found an image that explains it nicely. So if this is Git with snapshots, every new piece of paper in the image is a new snapshot, a new file version. So if this is the initial state, then to get here, we have switched line, the first and the second line, and changed 3 line into 4 line. And in this case, we replaced 1 line with 4 line. This is the end result. But this is what gets stored, so snapshots, whereas with Pijul, the first version of the file is just three additions, and then it stores that there's 1 removal, 1 addition, 1 removal, 1 addition, and again with this one. And to get to the final state of the file, Pijul just walks around this list of changes and deduces that this is the final version of the file. So in theory, let's just demo Pijul for a bit. So we will return here. Let's stop the fossil UI and go to the Pijul folder. Init demo, which initializes our demo repository. Just like Git, you can ask Pijul for a status. I'm not in a repository, of course. That makes sense. Embregts master, nothing to record, working tree clean. So let's start to record some changes. And I want to copy this sample.java that we created in our fossil repo and just paste it in here. I think I have to rename it to make sure that IntelliJ is not complaining about stuff. And let's just go ahead and add an implementation that actually generates a random number. So I've copied this this method from the thread local random class. The second parameter is exclusive. So if we provide it with 1 and 7, then it will generate numbers between 1 and 6. Let's add this file to our repository. Just when we're at it, we can also create directories and add the directories to Pijul. So with Git, this is not possible because there always has to be a file in a directory. But with Pijul, you can just add directories like this. And now we are hitting Pijul record. And the output that I'm getting right now is the interactive record. So for every addition that I did, it will ask me, shall I record this change? And the letters that it provides are all kinds of options. So yes means yes, record the change. No means no, don't record it. few other options. A means, for example, record all changes, so also the one that are coming after this, and I means ignore this file locally, so add it to the ignore. In this case, I want to add change, and I also want to add the directory. And the name of the patch is provide a better random implementation. That recorded the patch. And you can ask for the log, for example. Yeah. Another thing I want to show you has to do with reordering patches. And I want to create a new repository for that. And it's about the movies I see at night and the beers I drink. So I call the repository beers and movies. And the first thing I need to do is create a README. I'm not going to provide any content, but just add it to the repository and say Pijul record. You can also provide -m initial patch. So yes, record this change. And now I want to create a branch. Well, in Pijul, this is called forking. And I'll fork the branch to make sure that I can keep changes for the things that I'm going to watch and drink next week. Branches, there are two branches, master and next week. So let's go back to master, check out master, and create a file that is called movies.txt. And let's add something to it. For example, the movie that I saw this week is The Shining, for example. I've added The Shining. I'll add the file to the repository, movies.txt, and let's record it. Record -m, not initial patch, but watched a movie. Watched a movie. Record this change. Now I want to drink a beer with my movie, so I will edit the beers txt, and I have drunk Grimbergen double. This is the beer I drank last night. Add beers txt. -m, drink a beer. The change. Now I want to watch another movie. So I added the movies txt again, and I will add, I don't know, Forrest Gump. Just the first movie that comes to mind, right? Added the movie again. Add movies txt. Record. Watched another movie. Yes, record this change. Okay, let's look at our log, and we see four patches. The initial one added a movie, drank a beer, and added another movie. Now, if we check out, sorry. Now, if we check out the other branch, no, not yet. Did you see that? Check out next week and ask for the log. Of course, there's just the initial patch. So say I want to, next week, I'm not going to watch a movie, but I'm going to start with drinking a beer. I just say Pijul apply this hash code and Pijul log. The patch drank a beer has been applied. Now, if I want to watch Forrest Gump instead of The Shining, I will to Pijul apply this patch, which is the Forrest Gump patch. And now something interesting happens because it says missing dependency. And this makes sense because I want to add a patch that is an edit of movie txt, but the movie txt file is not even present in this version of the repo. So it has a dependency on the patch that added the movies txt, which means that I must apply this one first. And after I've applied that one, then I can apply the edit of the file. And if I ask for the log right now, I will have initial patch, drank a beer first, watched the first movie, watched another. In the new version of Pijul, so this is Pijul 0.12. min version minus version. In Pijul 1.0, this will be fixed in the way that dependencies are applied automatically. And I want to talk a bit more about new versions of Pijul. Because there's a bad thing about Pijul right now, and that is that 0.12 was a preview version for research purposes, and they used it to make their mathematical theories about the sound theory of patches complete, and to prove that it actually works in the long run. But of course, the system is also bootstrapped. So this means that there's a bug in your system and you use your own system, it can be very hard to get a previous version back and in working order again. And this is exactly what happened when they were working on the version beyond 0.12. A user reported a defect regarding the unrecording of patches that were previously involved in a conflict. And when they found a solution, it meant that a new patch format was needed, along with a few new algorithms. So they decided to make breaking changes for version 1.0. And they are, this is in alpha stage right now. Actually, they are trying to move towards beta as we speak. And it means that a lot of things are changing. So of course, this will have something to do with the popularity. So the patches that I showed you in 0.12, they will be called changes in the future. This is what I already said, dependent changes will be applied automatically. So in the demo, I had to do it manually, but it will be done automatically. Branches, they will rename to channels, and they will try to add better support for large files and repositories by doing some compression. And the interactive recording screen that I showed you, it will be replaced by a changed draft screen. I'm not sure if you ever used Git Rebase Interactive, but it will look a bit like that, so that you have to set some options in an editor file, and based on the options you set, the additions are recorded or not. But I can't show you the version 1.0. I have thought about it, but the demo didn't really translate very well. And I've had contact with the maintainers, and they said, yeah, you should really wait for the beta version at least. An additional problem is that they're also working on the documentation right now, and it is lagging a bit. So I find personally that the documentation for 0.12 is a lot better than version 1.0. So maybe I'll try to contribute to it myself a bit more. So I think it shows potential, but we really have to wait and see how the 1.0 version turns out. So lots of unknowns. Well, the wait is finally over. It is prediction time, which is about time, right? So let's compile a short list of the prediction variables that we have assembled until now, which was killer features, hosting platform support, open source community support, and the handicap of a head start. I will score the various version control systems on these 4 variables. So if you see features, I think Pijul has the best features, the fast branch-based versioning, because it can make sure that you don't get repos that are messed up, you know, like with rebasing and cherry picking and commits that are lost. You can never get into an inconsistent state. With Pijul and with Git, you can. We've all had this experience that we have to explain to our team members, why is my Git repo in such a strange state? Well, this just can't happen with Pijul. Fossil is also, it has show descendants, and it has this integrated developer website thing, and it is good suited for small teams, but I think the features are a bit less killer. Then we have to talk about hosting. Well, of course, Git wins this round. There are 19 different hosting websites that support Git, according to Wikipedia. Mercurial has 9 different hosting websites. Azure DevOps is the single one for TFVC. Fossil and Pijul also both have one, but they are maintained by their own teams, so there's potential to grow in this area. So I've given them like a neutral score. Open source development, Git and Mercurial have proven already that they contribute massively to open source. Team Foundation just doesn't. Fossil, I'm not too impressed with Fossil on this one. So because you don't need the dedicated hosting platform, according to Fossil, they tend to tailor the product to small teams that are physically at the same location and not spread out across the world. Well, that's not the best support open source development can have. Pijul has a Pijul nest that shows a bit more potential. And finally, dominant. So the handicap of head starts, obviously Git and Mercurial suffer the most from that, and the other 3 don't have the head start. So these are the final scores that I have compiled, which means that the original prediction that I showed you must be altered a bit according to this course. So Pijul should come out a bit further, Fossil also a team foundation a bit lower, and Git and Mercurial just about the same, maybe a bit higher. So actually, this is what I've come up with, which is of course an approximation, but what I think is that Git will still be around in 2030, just because the massive open source support and the hosting capabilities. But Pijul could really grow into, I don't know, the third or the fourth used version control system, but it really depends on its version 1.0 and the hosting support, of course. And Fossil, I think, will gain a place somewhere below for small teams. But what I have to say about this is, if, for example, GitLab announces we are going to support Fossil, these figures will change drastically, of course, because that's a large influence in its popularity. If you're really interested in the subject and want to read more, this is what I read in preparation of this talk, the Beyond Git blog post by Paweł Swiatkowski. It's a great summary of the topics. The Fossil versus Git wiki page by the Fossil team is great. It explains very well why Fossil could be better for your team because you're a small team that is working on location. A bit about the inner workings of Pijul, which is this one. And if you just want to try out Pijul for a bit, you can, using the Katakoda website. It will spin up a Docker container for you, and you can just try it out and have it record some patches for you. So now what? What do you want to do as a developer now that you know this? Well, these are the things that's stuck with me. A lot of projects are nothing like the Linux kernel, so just try Fossil for a change for a new project and see if you like it. And also, if you've had numerous discussions about Git snapshotting and about repository being inconsistent after rebases or cherry picks, maybe Git is too technical for your team, so try Pijul for a change. Though I would advise you to wait for the version 1.0. And with that, I think we have time for a few questions. So if you have a question, put them in the chat or just unmute yourself and I will try to answer it. I'm still finding the chat right now, just a moment. Not sure why, but I can't see the chat anywhere. Ah, here it is. Yeah, I'm getting there. Sorry. Okay, so I see that the moderator said 5 minutes left, and he's very right, so thank you. Someone asks, Fossil seems risky because of storing it in one single SQL live file. Would you agree? Well, yes, I would. So I've provided some resources on the fact that this file gets very large very quickly, and also if it if it becomes corrupt because the drive that you're storing it on is corrupt or something, it's very old. That's risky. But I have to say that I would be surprised if Fossil wouldn't have any resources on this. The website is quite extensive, so if you would search on their website, I think they will have like a remedy for this. Of course, you could just back up the file and have a backup strategy in place that you won't ever lose it. You would have to read up on the Fossil website for more information. Congrats on this nice talk. Well, thanks very much. I really like the topic, so it was more like a hobby for me. Johannes asks, what is with the distributed nature of Git in that every local clone contains everything? At least Fossil seems extremely server-centered. Yes, Fossil is a bit server-centered, a bit more server-centered, because it focuses on like bringing up this web interface on every developer's machine if you want. And it says it's distributed, but I haven't really seen the benefits of the distributed approach when using with Fossil. But on the other hand, I really have to start using it with more than 2 people. So I've used it with 2 people, but not more than that. So maybe that's the point where the benefits will become clear. Pijul is really focused on distribution, and you can see if you open the Pijul mess. that a lot of projects are worked on with a lot of people around the world, so a bit more like the Linux kernel. And Thomas asks, are there conversion tools from Git to Fossil Pijul? Yes, there are. Pijul has included it in its version 1.0, so you can try it out with the 1.054, I guess, is the last subversion, 54 alpha. It has a Pijul Git command, and you can just provide a Git repo and it will convert it to Pijul format. I've tried it out and it can take a while, so start it late at night and check back in the morning if it's finished, because it tries to maintain all history. Fossil has a similar tool to import a Git repo. Yeah, so they are ready for Git conversions. And the other way around, I'm not sure, but I guess you don't need that in the short term. So, okay, I see I've spent 15 minutes already. So if there are any more questions, I'll just put my contact info up on the slide. So the slides can be downloaded at the JCon website right now, but also via this link. This is my website with other speaking engagement. You can contact me on Twitter if you want to ask any more questions, or via email. I'll try to answer as best as I can. And yes, Theo, the slides are available. So via this link or in the schedule on the JCon website. So the only thing I have to do is thank you very much for your attention. Hope you enjoyed it and enjoy the rest of JCon massively. Thank you.